Hi folks, Mr. Long here for a screencast on how to solve the simpler versions of exponential equations. Exponential equations really are no different than any other type of equation. You want to make sure the left side and the right side are equal. Okay, that's the whole idea. The left side and the right side are equal. So if we look at this exponential equation there, 10 to the x equals 10 to the negative 3. You're supposed to solve for what x is. Well, if we stop and think about it, we do know something about these equations. So first thing I would say, does 10 equal 10? All right, so does this 10 equal this 10? That's not a very good 10 there, is it? Check, it does. Well, if that's true, then this has to equal this. So therefore, x has to equal negative 3. And we're done. Okay, so that's, I mean, obviously you're not going to get many questions like that because it's so too easy. So let's try another one. 2 to the 5th equals 2 to the negative 2x minus 19. Well, yeah, we're supposed to solve for x. And we want to make the right side and the left side equal. Okay, the left side and the right side equal. First of all, does 2 equal 2? Check. Well, if 2 equals 2, then this 5 has to equal that negative 2x minus 19. So we write an equation. 5 equals negative 2x minus 19. And I think you know how to do this. Add 19 to both sides. And then we get 24 equals negative 2x. And then we divide both sides by negative 2. And x ends up equaling negative 12. Now, if I wanted, I can sub back in. To check my answer. Okay, so remember that, again, you can always sub back in and check your answer. And when you're, by the way, when you're watching these videos, you can rewind and replay. Okay, this is the harder one of the first few that you're going to do. So take a look at this. You've got a base of 9 and a base of, well, I have to do a 27 because it's in the bottom, right? So does 9 equal 27? Of course it doesn't. So now we need a common base. Okay, a common base. So how do we find a common base? Remember that common bases occur in the same row. So what I'm looking for is a 9 and a 27 that occur in the same row. Well, it's pretty easy. 3, I know 3 squared is 9, so I'm going to look across. Oh, look at that. I've already got it pretty easily. So this 9, what is that 9 worth? It's worth 3 squared. And then I'll put the 3x outside it, right? So I just replaced 9 with 3 squared. And that equals 1 over 27. So 1 over 27. Well, what's 27 worth? 27 is worth 3 cubed. Okay, but I cannot represent that with exponents like that. I need to have a base of 3 on the top, right? Not in the bottom. So let's see here. I'll put an arrow over here because I've run out of space. So the first thing I have to remember, my exponent laws when I multiply, when I have an exponent on a power. So that's an exponent on top of a power, 3 squared. Well, I multiply those. 2 times 3x is 6x. So I'm going to end up with 3 to the 6x equaling 3 to the negative 3. Because remember that repeated division is nothing more than negative exponents. Okay, that represents it. Now 3 equals 3, so I can write that 6x has to equal negative 3, divide by 6, divide by 6, and x equals negative 3/6, which is negative 1 over 2. And that, folks, is my final answer. Okay, so that's our screencast for introduction to solving exponential equations. There's going to be another screencast with some more complicated examples, but for now, that will certainly get you going. Okay, and you're going to want to watch the other screencast as well before you do your practice questions. Good luck on your work.